So let's get started. Good morning, everybody. We're going to talk about MongoDB and Spring, an interesting, exciting combination for many different reasons, and you're going to learn about some of those this morning. Spring is the most widely used application programming framework for Java. Actually, I'm not quite sure whether that is true. I didn't Google it. I didn't read an article about it. This is what I have seen in the past 10 years. I'm a consulting engineer with MongoDB, which means I work with our customers to help them get the most out of MongoDB. And in the past 10 years, I have never seen a single Java application that was not using Spring. It's everywhere. Some of my consulting colleagues have assured me that there are Java applications that do not use Spring, but I have never seen one. So it's really ubiquitous out there. Everybody is using Spring because Spring is great, right? You can write web services with it, you can write microservices with it, you can do batch processing, and it takes away a lot of the groundwork, a lot of the infrastructure to allow you to write incredibly complex applications very, very quickly. And of course, when you use Spring for all of these kinds of things, you want to use MongoDB, and you would like to use MongoDB with Spring as well. So any Java programmer who decides that MongoDB might be an interesting database for them, they want to use it with Spring because that's what you use for your Java application. Now, I have to say that this fact, when I became aware of it, scared me a little bit at first because I'm the MongoDB consultant. I know MongoDB very well, but I did not know Spring very well because Spring is not written by MongoDB. It is not our driver to talk to the database. Actually, Spring does use the MongoDB driver underneath, but Spring does a whole lot of different things with it, and I didn't really know about it. So I might be tempted to say to a customer, I see you are using Spring. Well, I don't know anything about Spring, so you're on your own. When you have a problem with your application, you're on your own. Sorry, this is not MongoDB software. Well, that is not a particularly good answer. You might say it's an unacceptable answer because everybody is using Spring, and as MongoDB consultants, we ought to know about that ourselves. Now, today, several years later, there is an ongoing interchange between the Spring developers and the MongoDB, especially the Java driver developers. So we have an open Slack channel, inter-company Slack channel, where we synchronize our activities. When there is a new MongoDB feature coming out, we talk to the people on the Spring side, say, hey, what's the best way to support that? And the other way around. So there is really an ongoing exchange, and everybody tries to make the two, MongoDB and Spring, work together as smoothly as possible. And also, we on the consulting side are learning more and more about Spring and help our customers really to get the most out of these technology combinations. However, MongoDB is not like other databases. We all know that. It has been stressed many times just in the keynote. MongoDB, or the other way around, classical databases, relational databases have this rigid row and column format in which the data is stored. And in order to use that data, a framework like Spring transforms that and turns that into Java objects, which is what Java programmers would like to program against. That's a much more convenient way to work with data, talking to these objects. MongoDB is a document database, and exactly the same thing is already happening in the database. In the database, we already have documents or objects that look very much like what programmers would eventually like to use. So, given that we have a different database underneath, we might consider whether we could use different programming techniques to get the most out of that database. This talk is about exactly that. Are there any special considerations? What should we be aware of when we program against a document database as opposed to a classical relational database? This talk is about just that, so that we get the best out of MongoDB when using it together with Spring. Here's our agenda. Firstly, this is not going to be an introduction to Spring. We just don't have the time for that in 30 minutes to introduce you to that. I assume that most people here in the audience are familiar with Spring, but even if you're not yet that familiar with it, you will benefit from this talk because the concepts are fairly general, and the moment you are applying that to Spring, you will realize what I'm talking about and what this may mean to you in your application development. I have two main topics I would like to cover. The first topic I have already alluded to. It is the question, when I have documents in the database, should I map these to Java objects in my program, or should I not do that, and what are the implications of that? That's going to be our first major topic. And the second major topic is pagination algorithms, which are especially important in batch processing. When you process large amounts of data, millions of documents, and you do that in batches of 1,000 or 10,000 documents, what algorithms can be used there and what are the implications of that? There are lots more things to cover, but I focused on these two areas because they are particularly insightful to understand what you can do better when you use MongoDB and Spring together. So let's jump right into the first topic, to map or not to map. How do we get data out of the database and make it accessible in a way that Java programmers would like to use it? Let's review some basic Spring programming techniques. We have a document in our database. This is the simplest document you could imagine. We have a single key value pair. We have a key A, and the value of A is the number 123. This document sits in our database, and the typical technique in Spring is to say, we build a mapping class. In this case, it's called simple document. It has a single field, single integer field, and a getter and a setter for that field. So this is what we call a POJO, a plain old Java object. And Spring is designed to actually map the document to this Java class, to instances of this Java class. And then we run a query against our database, which could look like this. The template object here is our Java driver, the Spring Java driver, Spring MongoDB driver. We run a find, a given query, and we specify the class to which we want to map the result. In this case, it's the simple document class. And then once we have our list of simple documents back, we can fetch one of those. We can use the getter on this class to actually access the instance variable. So that's fairly straightforward Java programming. Now, there is an alternative to that. We could say, why would I use a mapping class here? I could actually use org.bson.document as a mapping class. This is the class that the Java driver from MongoDB provides. The data arrives as an instance of org.bson.document. This is actually a modified hash map, right? It's a hash map with key value pairs, few extra methods, and that allows us to access the data directly. And the code, when we actually want to do something, looks very similar, right? We have to retrieve a key value pair. The letter A here is the key, and we just get our value out. So that's very, very similar programming. And of course, we should ask, what are the pros and cons of using either approach? Let's look at a slightly more complex example. This document has also a single field. It's called L, and L is a list of documents. So now we actually have a more complex structure. We have an array, and the array consists of documents by themselves. Classical Spring programming, we would use a mapping class, complex document, single instance variable, which is a list of simple documents, and we have a getter and a setter for this variable. This is what a typical query would look like. We use complex document.class as the mapper, and then we have the print statement here that actually goes into the list of results, gets the first element of the list, gets the list itself, and then the instance variable of the first embedded document. This is how we could do it without a mapping class. We just specify org.bson.document as our mapping class, and then we can program against the org.bson document in much the same way. We have to do a little typecasting in here to make sure that we actually get the appropriate methods, but then it is absolutely possible to program directly against the org.bson.document. So what are the arguments in favor of one or the other approach? When is the mapping to a dedicated POJO class useful? Well, first thing is we want to enforce object structure. What we're doing is strict typing. And of course, Java is a language of strong typing. It is a language where we take very great care to have exactly the types we want to. We enforce that structure. Spring is very much in that tradition. We are using strong typing for our Java objects so that when we get something from the database, we know it's an object representing a customer and not an object representing an order, right? So we don't want to mix up these two, and we want to enforce strong typing to have that straight. This makes business logic easier to implement because we have our dedicated getter and setter methods, or even more complex computation methods in these mapper objects, and that is easier to implement. It is also very useful if we have an underlying relational database. In a relational database, a business object might be spread out over many, many different tables, and the only way to reasonably interact with that is to turn it into a real object so that we can access the data conveniently and really program in an object-oriented way with concepts that are taken in from the real world. When might this mapping not be so useful? If we use a generic mapping type like org.bson.document, we are dealing with a flexible object structure. In other words, we are using weak typing. And you can see the two orange words here, strong typing and weak typing. This is a question that has moved programmers and architects since the beginning of time, or maybe like the last 40 years, right? Strong typing and weak typing is a constant battle in programming. Java definitely on the strong typing side. If you look at a language like Python, Python is the direct opposite, right? Python is almost explicitly an anti-Java, saying that we don't want to have strong types, we would like to have weak types. And the argument that people usually make for weak typing is developer productivity. Developers know what they're doing. We should not put any barriers in their way so that they can do whatever they need to do, and they will do it right. Whereas the conservative view on the strong typing side is always to say, no, developers will make errors. We have large teams of developers all writing the same data. Somebody needs to enforce a structure so that they don't make mistakes at the expense of productivity, right? This is the battle, and we're not going to decide that today. I'm not going to tell you which one is right, because there are arguments that can be made for either. What you should be aware of is you have both options. Even in a strongly typed language as Java, you can choose between a weaker approach to have more flexibility. Look at a use case like this. This is what we call schema evolution in MongoDB. Imagine we have a customer record. The customer record has, among many others, a field called email. The email is a single string. It's the email address of the user. At some point, we decide that users can actually have more than one email. So we would like to represent the email as a list of strings. Now, such a schema change in MongoDB can be done just on the fly, because all the documents in a collection do not need to share anything in common. So we can go ahead and represent the email as a list of strings rather than a single string. We do not even need to change the existing objects. They can be happily coexisting with that. Only new objects get a list of strings here. If we have a weak typing approach, all we need to do is make our application a little bit more intelligent. Before returning an email, we have to look, are you a string or are you a list of strings? If you're a list of strings, I'm going to return the first one. If you are a single string, I'm just going to return that. Right? So the application needs to be a little intelligent to distinguish between the two formats, but then we're just fine. That's the power of MongoDB, schema evolution on the fly without having to change existing data. We might come up with a version 3, where we say that I want to label the email addresses. So we turn the email list into an email document where we have two fields, work and home, and now we can distinguish them by function. We could have all these three versions together in the same collection, and yet our application only needs to understand what each of these means, and they can happily coexist with each other. That's some of the flexibility in MongoDB. It could scare the hell out of a Java developer, and probably other developers, to have this coexisting, but it's possible. Sometimes when you have terabytes of existing data, it may not be an option to change your existing data. You may have to go with techniques like this, and this is one of the big advantages of MongoDB. So that's clearly a case where weaker typing might help you. What else might be in favor of not doing a full mapping? You don't even look at the data. But there are definitely use cases where you're not interested what's in your objects. For example, imagine that you're writing a microservice. You get a REST API call, read something from the database like a customer object, and now in your Java application, what you're getting is BSON, binary JSON from the database. That gets mapped to a document, which is a hash map, and the document gets mapped to a POJO, only to be serialized again as JSON and then returned to the caller. That's funny, right? But just mapping it in order to throw it away immediately, just because that's the common schema by which we program against the driver. What we could do is simply take the binary JSON, maybe serialize it or convert it into textual JSON and return it to the client. We don't need to map that. That makes it much easier, right? So in many cases, we never actually look at the data, and there's no point in actually mapping it to a real Java object. And finally, another aspect of this mapping approach is performance. It is useful to try and understand how much does this cost me? Because obviously, when we map to a full-blown Java object, we're doing something. And this something is going to cost something. It's going to take some time. The question is, how much? And so I did a few experiments to understand that. I call this deserialization cost. We have data arriving from the database, and we need to deserialize that into an object structure. And in many cases, you may have a structure like this. You make a call to the database. That has outbound latency. We may have a call from the East Coast to the West Coast. Latency typically 30 milliseconds. My query against the database may be a complex one, so it may take 100 milliseconds. Then I have a latency hop again back to my caller. And when I get to the caller, that's when I perform my deserialization step, typically on the order of microseconds. Obviously, in such a scenario, deserialization is completely irrelevant. But you're never going to see that, and it's not worth thinking about it in terms of performance. Another scenario might be this one. We have a database that is very close to us physically, maybe even in the same data center. We have a very simple query that takes less than a millisecond to execute. We have an inbound latency, once again, less than a millisecond because it's a local data center, but we are returning lots and lots of documents, or really big documents. So deserialization now takes up a much, much more significant part of the overall query latency. So we really need to distinguish between these cases. In many cases, deserialization will not cost you anything discernible. In some cases, it might. So here are some experiments. I did this on my local laptop, more or less the same data center. I have a simple query, just getting one document back from a collection, and I used these different data types here. Fairly simple ones, but we have nested structures in here. You can see the basic structure. The columns here are execution times in microseconds. So that's really fast, less than a millisecond. In the column raw, that's when we map to arg.bson.document. In the middle, we have a mapping class, just as I showed you in my examples, and you see the slowdown in the right column. And you can see here we definitely do see something, right? Not overly dramatic, 11%. The string case is even faster in the mapped case, because strings are often specially optimized. So we see some slowdown. And the reason we see some slowdown is because my query is already very, very fast. Right? Local laptop, return a single document, right? So the deserialization is visible here. Let's make it more dramatic. We're reading 100,000 documents in a single query, also on the local laptop. It gets more dramatic, but it doesn't get completely out of hand, right? There is one case that looks particularly bad, like 243% slowdown. Other cases are still well in the double digits, 47% and so on. So in this case, obviously, deserialization makes up an even bigger amount. However, also the raw case, the unmapped case, costs more time because we are reading lots and lots of documents. So what this shows you is that we can have a significant performance impact from the deserialization. And I have definitely had customers who were fighting for every single millisecond in their calls. And when I told them that, hey, your mapping process in Spring is costing you time. Maybe we should consider taking that out of the picture just to get below 100 millisecond execution time or something like that. It definitely did occur and was a real help in this particular case. Let's try and summarize that. The deserialization cost will get important. The simpler your query, the closer your server, because your round-trip latency is less, the more documents you return, and the larger these documents are, because they will typically consist of lots and lots of additional objects inside, and that takes time. The major part that takes time here is creating new objects. Right? That's the most expensive operation in the virtual machine, creating new objects, and by turning everything into POJOs, we need to create these new objects. We've talked to our friends on the Spring side about this, and they saw these numbers and they didn't like them. And I said, yes, we know some places in our code path that we can optimize, and this really is big motivation for us to optimize that. So expect that in future Spring releases, we may see this gap narrowing significantly as they look to address this. So that's an example of our great cooperation we have here. All right. That was the first area I wanted to look at, the mapping versus not mapping of objects. Clearly one of the central areas of Spring, part of its central philosophy. Next thing I'm going to do is we're going to look at batch processing, because we saw some very significant, even dramatic cases with customers there. This is a typical setup of a batch job in Spring Batch. Creating a batch processing step, we got the builder, and inside the builder, we have this line here where we set the chunk size. So in this case, we are reading from a certain data source and writing to a data source, and the chunk size is 1,000 documents at a time. Now, when we look at how this is implemented in Spring, it uses the skip limit pattern. So we read something from our source collection, and we tell it to skip the first 10,000 documents, give us 1,000 documents, and process them. After that, we make another call to this collection, another search, and we tell it to skip 11,000 documents and return the next 1,000 documents, and so on until we reach the end, skip 19,000 documents and give us 1,000 documents. Now, the skipping takes time. We actually have to get all these documents and skip over them before we get to those we actually want to return. The skip limit pattern can be highly problematic. Skip limit performs the same query over and over again, only to ignore more and more of the results. Later pages take longer and longer to retrieve. I think we all have seen that in interactive applications, right? The further you get down in the paging numbers, the longer it takes to retrieve the later pages. That's because we're doing skip limiting. Pagination without sorting is meaningless. If the database returns the documents in some random order, the pagination is completely off. So we need to have the data sorted, maybe by the _ID field, maybe by a date field in the data. However, if this sorting is not indexed, that's the worst possible thing that can happen. Imagine you want to return 1 million documents, 20 documents at a time, but to get those 20 documents, you have to read all 1 million documents every single time, sort them from beginning to end, just to know what the next 20 documents are. That's terrible. And I had a customer who was suffering from exactly that. They were having really many very expensive queries in their database. And what's happening here? What are all these queries? I don't know. We have a batch job that runs at night, but it doesn't do that. And we realized, no, this was doing skip limiting. Actually, your single batch job turned into thousands and thousands of queries who were very expensive because it had to do the sorting all of the time. So skip limiting can really go haywire. So we went to the customer and said that, what's happening here, right? They said, we're not doing any skip limiting. Turns out Spring is doing that, right? Spring actually has this implementation, and the question is, can we do this differently? Can we do this without skipping and limiting? A few alternatives, right? One of the ways to deal with this is to remember how far we've got in the previous page and use that as the starting point for the next page. Another alternative is to say, let's have an open cursor in the database and just keep reading from that cursor. So that allows you to do a single query and just read the results from the open pipeline from the database. This is how it would look like if we remember the point to which we got in the previous query. A query like that with sort and skip and limit turns into a query where we have this clause in there. Date must be greater than the last date we had on the previous page. We're still sorting by date, we're still limiting, but the skip is now much, much more efficient. This last item can be remembered either on the client side or on the server side. It can be session-based or query-based, right? If we have a client-side session, we can store the place to which we got in that session. Oftentimes, REST APIs are, of course, stateless. So we might have a hard time actually storing that info somewhere. But if we can do that, that's a much more efficient alternative. However, it has disadvantages. We still need to run a new query for each page that we return. If the sorting is not indexed, the query is still fatal, right? Even if we just need to find the point where we need to continue, that requires us to sort the entire contents of the collection. So we need to have an index on that. Let's take a look at the other technique, leaving the cursor open. So we might have code like this. What we get from the collection is a Mongo cursor or whatever iterator construct we have. We can continue reading from that. The cursor remains open until we explicitly close it, or there's a timeout. The normal timeout in MongoDB is 10 minutes. So after 10 minutes, the cursor gets automatically closed. But we can try to keep processing and use less than 10 minutes, or we can extend the opening time for the cursor if we want to do that. And so we are able to serve additional requests from the same cursor. This cursor is stored entirely server-side. The nice thing is that the client doesn't need to know anything about it. Right? I'm telling the server, give me the first 1,000 documents. Process the 1,000 documents, and then I go back and say, give me the next 1,000 documents. I don't need to remember anything. The server says, oh, yes, I have an open cursor that sits exactly at that point. I wonder who made it like that. But anyway, let's use that cursor, right? It happens to be there. So that's very, very nice because nobody needs to take care except this logic on the server side. We can use a client session to store this, but we can also just remember the position of the cursor in that particular query to decide, okay, this cursor can be used for this query. Cursor swapping is no problem. By this I mean there's one client that reads the first 1,000 documents. Another client comes in and wants the next 1,000 documents. That's fine. It kind of steals the cursor. But when the original client comes back, we can simply open a new one, right? If we realize that we have no open cursor that stands at the position we want to read, we can simply open a new one. That will cost us some time, but cursors can typically be reused quite a few times. Advantages are, ideally, only one query gets run to read an entire collection of data. The cost, even of sorting, is amortized. If we do a very expensive sort, we might be able to do that. We only have to do it once. So, how does this translate to Spring? Spring has a large inheritance hierarchy of these different kinds of reader types. There are readers that do this open cursor pattern. Unfortunately, the Mongo item reader is not one of them. The Mongo item reader uses skip limit pattern. Once again, we only had to talk very briefly to our friends on the Spring side and said, oh yes, absolutely. The Mongo item reader needs to do the open cursor technique as well. And that request is already in, so in a future Spring version, you will see that coming up. What can you do until then, right? We should try to avoid it, but maybe we can't until the Spring developers give us the new version. With the current Spring version, what you can do is increase your batch size. If you have a batch size of 10, that means many, many, many queries for 1 million documents. If your batch size is 10,000, you have reduced the number of queries by several orders of magnitude. So make your batch size as big as you can to reduce that effect. Make sure your sorting is indexed. If your sorting is not indexed, you have to read the entire collection for every batch. So that's not a good idea. And with that, we are reaching the end of this talk. Brief summary. Once again, Spring is the most widely used application programming framework for Java, and for good reason. It's an incredibly useful environment. Using Spring with MongoDB is a great combination, very beneficial for both sides. Mapping documents to POJOs is an interesting approach. However, we have a document database that already has data very much in the form that we would like to consume it. So maybe we may not need to map it all the times. Skip limit pagination is a big problem and is an implementation weakness at this point, but will be addressed in future versions. And with that, thank you very much. Any questions?
Any questions, raise your hand. We probably can take like 2 questions since we already ran out of time.
Sorry, I have a question about the what is that? The mapping. So you mentioned about the Spring mapping. Is that also applied to the Mongo driver codec?
Does the Mongo driver do the same thing?
No, I mean I'm using the Mongo driver, and it provides a codec method that I can map the document to a POJO, basically.
Correct.
Is that the same thing as what Spring is doing?
Not quite. You are right. The Mongo driver can do the same thing. You can map to POJOs.
Yeah.
The Mongo driver is more efficient about that because the Mongo driver goes from raw BSON directly to a mapped object.
Yeah.
I haven't run the same measurements there because I wanted to focus on Spring.
Okay.
But the performance penalty is a lot less with the own Mongo driver, yes.
Yeah, I mean, I'm defining my custom codec for that. So
correct.
That will still be better than the...
Correct, yes. But the thing is, of course, performance is only one consideration here.
Yeah.
Right?
Yeah.
If that goes away, even in a future Spring version, great.
Okay.
But there are still other considerations.
Okay, thanks. That's my question. Thanks.
Let's take 1, maybe 2 more questions. I'll go here first, and you'll be next.
Most of the front-end applications, they need JSON, right? If you use Spring, mostly when you query the database, you convert it into a POJO, which you talked about is not a good way. So how can you convert BSON to a JSON directly and render it back to the front end?
There is an API call that does this, that serializes the BSON directly into JSON text.
And can you take a subset of the BSON?
If you need to manipulate it, then of course it may be useful to map either to a document or to a POJO, right? What I'm talking about is completely streamlining it through, right?
Okay,
you may be able to do some processing there, but the more complex that gets, the more it makes sense to actually map to a more complex type.
So is there a way when we query the document, can we take a subset of a document?
We would have to talk about that independently.
Okay.
It may be possible, yeah.
A question about the cursor solution. In your experience, have you seen performance degradation on high number of open cursors? Is that a concern?
A high number of what?
Open cursors, for example, if you have every user session maintaining 1 or several cursors.
Right. I mean, cursors obviously take resources on the server side, but very, very small resources, right? And it obviously depends on how much traffic you have. Right? If you have 10,000 clients reading from your application at the same time, you may want to check how big are the cursors. Also, we have open connections for that, right? Can we support so many open connections? So that's definitely a concern. But in my experience, cursors take very limited amount of memory, and it's easily possible to keep many of them around.
Thank you.